Okay, everyone. So I'm going to do out the answer key to the practice with transformations of functions. I wrote out the answer key on my iPad, but I also wanted to show you how I would do it on the Desmos so that you can see me go through the same process that you go through, as well as I wanted to give you a verbal explanation on how to do the problems with the answers so that you can have it to refer back to while you do practice or study for the quiz on this topic. So first question here says, state the parent function, describe the transformations, complete the table, graph the function, and state the domain and range. So it's a lot of stuff, but I've broken it up into parts for you. So the first part says, what's the equation of the parent function? So when I'm looking at this function here, y equals 1/2 quantity x plus 4 squared, the parent function is going to be quadratic because of this squared. So the name of the parent function is a quadratic. And the, sorry, I'm trying to figure out how I can move this. There we go. So the name of the quadratic function is a quadratic, but the equation of the quadratic parent function is just f of x equals x squared. So on your computer, you have two options to type x squared. You can type the x and then shift 6 to get up into the exponent, or you can click on the keyboard and type x and then the squared button is here, so x squared. And that's my parent function. So then the transformations basically is what's different about the given equation compared to the parent function equation. And here there are two different things. So the first different thing is the 1/2 here. This is the a value. So I talk about like a being equal to 1 or greater than 1 or things like that. This is a equals 1/2. And when a is between, so I'll write this out, when a is between 0 and 1, the transformation is a vertical shrink, which basically means the graph gets shorter and fatter, like wider. So our first transformation here is going to be a vertical shrink by a factor of, and anytime I want to type math, I use the square root, so of 1/2. And then my other transformation comes from this plus 4 here. Since this is an inside change, happening to the x, we're going to shift, it's going to be a horizontal shift. It's going to be to the left 4, because remember, it's opposite. So we're going to go left 4 units. So here, we're going to say horizontal shift left 4 units. And that's exactly how I expect you to write it, that vocabulary and everything. So those are my transformations. Unfortunately, as I scroll down, this stuff would move, so I have to clear it. So if you want to annotate your problem or whatever on paper, pause the video, write all that stuff down. So once I've figured out my transformations from my equation, I then want you to use the equation to fill out a table so that you can graph. So what I'm going to do is I'm going to rewrite my equation down here, which it was y equals 1/2 parentheses x plus 4 squared. And what I'm going to do to fill out my table is I'm going to take each of these x values and sub them in for x and simplify using PEMDAS. So first thing I'm going to sub in is -8 for x. Use this type math feature here. So click on that. And I don't need the keyboard here. So I'm going to have y equals 1/2 parentheses. Instead of x, I'm having -8 plus 4 squared. PEMDAS tells me to do parentheses first. So -8 plus 4 is -4. So 1/2, don't drop your parentheses, -4 squared. Then PEMDAS tells me to do exponents, so -4 in parentheses squared. Guys, if you need to use a calculator, use one. See, this follows me. But it's going to be -4 squared, and I get 16. So if I go back, this is going to be 1/2 of 16, which is 8. So this is 8. You cannot just assume that the rest of the y values will be opposite of the x values. It just happened that way here. I cannot assume that every time. I need to actually sub in all of the x values. And the nice thing is copy and paste is a great feature, and you can just go through and edit the work. So when I subbed in x equals -6, -6 plus 4 got me -2. When I square that in parentheses, I get +4. Half that is 2. Keep going. So I'm going to plug in -4. -4 plus 4 is 0. 0 squared is 0. 1/2 times 0 is 0. And I'm going to clear this drawing stuff out of my way so I can scroll down. So now I'm going to sub in -2. Again, copy and paste makes it a lot faster. Some of you guys complain a little bit about using Desmos, but if you use the right tools, it makes it faster. So here I have -2 plus 4 squared. That's 2 squared, which is 4, times 1/2 is 2. Notice for my parabola, my y values are starting to repeat. That should happen because it is symmetrical, right? It is a U shape. So those y values should show up for 2 different x values. So it should have repeating y values. That should happen every time. And then one more we've got to do for 0. So we'll plug in 0. We get 4 squared, 16, and look at that, same as how I started, 8. So that's how you fill out the table and show your work. A lot of you are asking me, do I need to show all that work? I would recommend it. The more work you show, the more partial credit you can get on a assessment. So now I have to graph these points, and that's exactly what these are. These are just points. Like this is the point -8, 8. This is the point -6, 2, and so on. So I'm going to graph those up here. Purple. I'm going to go over to -8, 5, 6, 7, 8, up to 8. Plot my point. My next point is -6, 2. My next point is -4, 0. -2, 2. And 0, 8. And then when you connect this, you want to try your best to make it a nice smooth curve. I know that's hard on Desmos, so do the best you can. So something like that. Mine's a little wonky. Your graph should have some arrows on the end. It goes up forever. And that's what the graph looks like. And every quadratic should look like a U shape, either upside down or right side up. So then it says state the domain. The domain for every single quadratic is -infinity to infinity. Every quadratic, doesn't matter about the transformations. And then the range, the range is y values, bottom to top, so smallest to largest. So if I look at my graph, the lowest y value here is y equals 0. So the lowest y value is 0, and then it goes up forever. So my range is going to be 0 in a square bracket, comma, infinity in a regular parenthesis. Just like that. We zoom out. You can see this is problem number 1 in its entirety. Like I said, I'll also have a written out version of this, but this way you have some explanations for each problem. Right, on to the next one. So here, same directions, just a different equation. I'm having you look at something that involves a square root. So that should give away that the parent function is the square root function. And the equation for that, which I'm going to put in the box below to here, is the square root of x. And you can get to that by clicking the keyboard, square root x. Right, so equation of parent function just means, well, what is the parent function without any of the stuff around it? So now the extra stuff tells me my transformations. There are two extra things in this equation. There's this negative that tells me something, and then there's this +2 on the outside that tells me something else. The negative on the inside of the square root tells me to reflect over the y-axis. Negative inside is reflect over the y-axis. That's my first transformation. When I state transformations, I want to state them in order from left to right, like I read a book. So this is the first one that happens. We reflect over the y-axis. And then my +2 is an outside change. So it's going to be a vertical shift up 2. It's an outside change. It's not underneath the square root. It's changing our y values. So we're going to have that vertical shift up 2. So those are my transformations in this one. There are just 2. Again, I have to clear this in order to move on. So if you are writing this down, make sure you pause so that you can write it. So now filling out the table. Again, I'm going to copy down my equation, which was y equals square root of negative x on the outside plus 2. And what I want to do is I want to plug these x values in for x. So when I do that, in this first one, I'm going to have y equals square root negative, because I'm not replacing that first negative. Anytime I want to replace an x, I should use parentheses. So -9, and then outside the square root +2. In order to get outside the square root, you have to hit the right arrow key. So I'm going to simplify that. -9 becomes +9 on the outside +2. Square root of 9 is 3. 3 plus 2 is 5. So this is 5. Do it again. Again, copy and paste is our friend. So this is going to be -1, which is just 1. Square root of 1 is 1. 1 plus 2 is 3. And then last but not least, plug in 0. No such thing as -0. It's just 0. Square root of 0 is 0. 0 plus 2 is 2. And then I plot my points. So like I said before, this is x comma y. So -9 comma 5, -1 comma 3, and 0 comma 2. So I'm going to go up to my graph, and I'm going to plot those. -9, 5, -1, 3, and over nothing, up 2. And do your best to connect this with like a little half curve sort of thingy. And you should put some sort of arrow on the end. And that's what the graph should look like here. The domain here is a little tricky. Domain, we go from left to right. So as I'm reading this, my graph is coming this way, and it's going to stop at this point. Left to right. So the lowest x value here is actually -infinity. -infinity is a very, 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 very small number. And then my graph stops right here at this point, because I'm not very good with using Zoom to like create a video. So my graph stops right at that point. The x value here is 0. And so my graph doesn't go past that. That's my highest x value here. So my domain is -infinity to 0 inclusive. And then the range is bottom to top. So the lowest y value here is 2, and then it goes to infinity. Okay, if we talk about y values, the lowest y value is right here. This is y equals 2. And as this goes out, it goes up. So that's why it goes to infinity. So that's the domain and range. Now, that is the whole problem for you. It's exactly the work you should show, what yours should look like, the correct wording, everything. All right, moving on. So number 3, here in this problem, because this problem has absolute value bars, my parent function, the name of my parent function is the absolute value. And the equation of that is just the absolute value of x. The way you get absolute value, click on the keyboard, put the absolute value, x, close it up. So that's the parent function. There's a lot of things happening to my parent function here. I have a negative. That's one transformation. I have a 2. That's another separate transformation. I have a -1 inside my absolute value bars. That's a third transformation. And I'm running out of colors. I have a -2 on the outside of my absolute value bars. That is a fourth transformation. So there are 4 transformations here. The negative on the outside, so that first transformation, right? We go left to right. That first transformation is a reflection over the x-axis. Reflections are always opposite. So this is a reflection over the x-axis. The first one that goes in this box here is reflect over the x-axis. The 2 on the outside here, the 2 is a vertical stretch. Means our graph is going to get skinny. And get tall and skinny. Yeah. So the purple 2 is a vertical stretch by a factor of 2. And then the -1 is my horizontal shift right 1 unit. And then the -2, since it's outside, is a vertical shift down 2 units. Those are all the transformations happening here. Again, if you want to write that down, pause the video because I've got to clear it to move on. So I'm going to do that now. So I figured out all my transformations. Now I want to fill out the table, and I'm going to rewrite my equation. So I had y equals -2 times the absolute value of x minus 1 minus 2. This is going to look a little sloppy, but pay close attention. So I want to take these x values and plug them in for x. So I'm going to have, just let me clear this. So let me just write it out first. Y equals -2 absolute value, -1 minus 1 minus 2. All I did was replace that x with -1. work inside out, PEMDAS, inside out. Absolute value bars are just like parentheses. So I'm going to have -2 times the absolute value. -1 minus 1 is -2 minus 2. Right here, I have to take the absolute value of -2 first. The absolute value of -2 is 2. The operation between these two numbers here is multiplication. So this is going to be -2 times 2 minus 2. That's -4 minus 2, -6. Oops, I ran out of space. Basically, my advice is take this once you sub it in and put it in your Desmos calculator. It'll just tell you the value. If you use the calculator, you have way less error way less room for error. So honestly, I would say and you're going to get y equals -6. And follow that procedure the rest of the way through. Again, copy and paste is our friend. Put that in your calculator. Go to my Desmos calculator. Paste it up, -4. Keep going through all of them. -2. 2 more. Guys, if you're going to use copy and paste, make sure you click the type math first. We're subbing in 2 this time. Paste into my calculator. You get -4. And then 1 more. That's going to stink because I'm pretty sure all my work is going to be gone. Nice. Love that for me, guys. Okay, this was -6, -4. I think it was -2, -4. Then I was showing you the last one. So sorry about that. You can rewind to get it, or you can look at the written version. This should also equal -6. That just to be sure. Yep, all good. So now I'm going to plot these points. It's bothering me that this is not filled in. So now I'm going to graph my points. So -1, -6, 0, -4, 1, -2, 2, -4, and 3, -6. You should notice that this is a skinny V shape, which is exactly what absolute value should look like. Domain for every absolute value function is -infinity to infinity. Every single absolute value function. The range here is what's difficult. Remember, range is bottom to top. So if it's pointing down, it's going to start at -infinity. And this graph stops at this point, and the y value of that point is -2. So this is going to go from negative infinity to negative 2, square bracket. And like I said, some of the work is missing because I had to start over. But if you rewind, you can find the rest of the work for filling out the table here. All right, so that was taking a function, identifying all the stuff, graphing, and whatnot. Now we need to write the equation and come up with the equation based on all the information. Just kind of going the opposite direction. So here they're telling me my parent function is y equals x to the third, or the cubic. And they're going to take that function and they're going to do a vertical compression by a factor of 1/3. That means put 1/3 on the outside. So out front. So that's exactly what I'm going to do. The first thing I'm going to type is 1/3. F of x equals 1/3. And then I'm going to have here, it says a horizontal shift right 2 units. So that means subtract 2, right? Right means x minus 2. This is going to be an inside change. So since it's inside, I need parentheses, so parentheses x minus 2, and then I need my exponent cubed. There's no reflections here, so there's no negatives, there's no vertical shifts, so there's no plus or minus on the outside. We just have our horizontal shift right 2, which is represented right here by the x minus 2 in parentheses. Inside change. For number 5, we want to stretch by a factor of 3, which means a equals 3. So we're going to put an 3 on the outside. So it's going to be g of x equals 3. Then we have a horizontal shift to the left 6 units. Left 6 units means x plus 6. Again, inside change, so it needs to be in parentheses. Our function here is the linear, so there's no squared, there's no square root, there's no absolute value, nothing. I'm just going to have parentheses x plus 6. So that's 4 and 5. Number 6, we have a reflection over the x-axis, so that means a negative outside. The first thing you're going to have h of x equals negative. And then my only other transformation is a vertical shift up 10. This happens last, and it's outside. So I'm going to put my parent function in. So I'm going to have absolute value of x. I'm going to add 10 to that. Last but not least, my number 7. So here I have a reflection over the y-axis. This is an inside change. So you're going to put a negative inside. You're going to put it with the x. So I'm going to have the square root. And this time I'm going to have negative x. And then I want to go vertical shift down 5. This is going to be outside change. So make sure you go outside the square root symbol. To get outside the square root symbol, hit the right arrow key and then -5. You don't want the -5 underneath the radical. So what I don't want to see is the square root of negative x minus 5 like this. This is a no-no. The -5 has to be outside the square root. So that's when I write an equation given the description. Oops. Feel free to pause this to write this down because I need to clear it to move on. Number 8, it says which graph best represents the given function. So look at your transformations here. Same thing as before. Here I have a negative, so that means it's going to be upside down, so flipped over the x-axis, right? Reflect over x. The negative's on the outside. And then the 1/2 is really the giveaway here since these are all upside down. The 1/2 here tells me that my graph is going to be skinny. Right? It's fat. Like it's going to be flatter, wider. So 1/2 is a shrink. So graph is going to be wider. So you want to pick the one that's the widest here, which is actually choice A. And if you look, it tells you that you are correct and to move on. The domain of any quadratic, as I said before and multiple times, is -infinity to infinity. Every quadratic, always. The range here, remember we want to go bottom to top for the range. So the graph stops at 0. So that's the highest y value, and it's coming from down below, so it's going to start at -infinity, comma 0. The graph starts really low and continues to creep up, so that's why it starts at -infinity. Oops. Another one like this. So here I have 2 transformations as well. The 2 out front tells me skinny, like tall and skinny. And the -1 tells me shift right. So I believe it is choice C, that is the skinniest graph, and it's shifted over to the right. I am correct. Domain for all absolute value is always -infinity to infinity. The range here, again, bottom to top, so the smallest number here is 0 to infinity. Right, because it starts, the y value right here is 0, and I go up forever to infinity. So here it says match the equation with the graph. So there's a couple of different things going on here. And basically you just have to, you can click on it to make it bigger. You have to be able to recognize what the parent function looks like versus the not parent function. So here, I'll start with a graph. Here's an absolute value graph, and it's right side up. It looks pretty normal, so I'm going to say that that is this, and I'm going to pair those together. I have another absolute value graph, and it's upside down, so that means that I'm going to have a negative on the outside, which would be this. This squiggle here, this is the cube root function. I'm sorry, the cubic, right, x to the third. So I'm going to find my x to the third and match them. I have another x to the third one, looks pretty similar, except it's flipped. So I'm going to find the one with the negative. So I have those. And then the rest are all parabolas. They're all quadratics. So I have to kind of figure out what's differentiating them from each other. So I'm going to kind of line all these up and line up all my equations and try to match. These are not the right answers. I'm just matching them, just moving them. So this first one, 2x squared. That means it's going to open up and it's going to be skinny. So it's either red or it's blue. And if I look at those really close together, the blue one is the skinnier one. So that's going to be that. -3x squared means flip upside down and skinny. So it's actually this green one here. Regular x squared means right side up and it's regular width, so it's this red one. And then negative 0.5 means upside down and wide, so it is purple. And the nice thing about the card sort was you could check your answer. So if I click this button, of course I got them all right. Wonderful. And that is the answer key. So when you get here, you can select which ones you are still struggling with and tell me about it here so I can best help you, or so that you even know what you can study for the quiz. Let me know if you have any questions. You can watch this and look alongside with the written out work as well. Feel free to contact for help or email me.